February 20th, 1943. North of Kasserine Pass, Tunisia. The battle report would never capture what German panzer commanders saw that morning. 5 M4 Sherman tanks, half hidden by dust and broken terrain, maneuvered as if guided by a single mind. Through binoculars, Oberleutnant Ernst Rudiger watched them advance, not in a column, not by prearranged signal, but in a fluid dance of precision. No flares, no flagmen, no motorcycle couriers racing through shell bursts. They moved as one organism, each tank covering the other's flanks, pivoting, halting, and accelerating in perfect sequence. For officers schooled in the rigid rhythm of Panzerwaffe doctrine, it was an impossibility. Inside Rudiger's Panzer IV, the crew's receiver hissed and popped with static. The few G5 set, state-of-the-art when designed in 1939, spat a jumble of voices drowned by engine noise. The 10-watt transmitter could barely reach 2 kilometers when the tank was moving. Most German vehicles carried receivers only. They could listen, but not reply. Every time the platoon leader's command tank was hit, coordination disintegrated. Now, through the haze, the Americans were proving another world existed, one where armor fought as a network, not as isolated guns on tracks. Their voices, carried by invisible waves the Germans could not yet comprehend, merged into a single battlefield consciousness. In the lead Sherman, Sergeant Ray McCulloch's throat microphone pressed against his neck as he called a bearing. Panther-shaped hull, left ridge, 800 yards. Copy 2-1, answered another voice instantly, calm and clear. Adjust right 50, fire for effect. The order passed through a dozen machines almost simultaneously. Turrets turned, guns elevated, and the platoon's 75mm rounds landed on target in seconds. To German observers, it looked supernatural. Tanks miles apart, acting with one mind, as if some unseen hand drew their movements across the map. The technology behind that coordination, an unassuming metal box bolted inside each Sherman, was called the SCR-508. Its 25-watt transmitter spoke on 20 to 27.9 megahertz, using frequency modulation, not amplitude. The difference was invisible, but decisive. Where AM radios filled with static whenever a generator sparked or a track squealed, FM sliced through the noise like a clean blade. Crystal-controlled channels locked each voice to an exact frequency. No drifting, no guessing. Every tank could transmit. Every tank could command. The result was what German field reports later described as impossible coherence. For the Wehrmacht, radio had always been the nervous system of blitzkrieg. Heinz Guderian himself had insisted that every command vehicle carry wireless equipment. But by 1943, German industry was exhausted. Fewer than 1 in 5 tanks left the factory with a full transceiver. The rest received receivers only. The Panzerwaffe's nervous system had decayed into silence. By contrast, the U.S. Army Signal Corps, working with Galvin Manufacturing Company of Chicago, soon to be called Motorola, had spent 1941 building something unprecedented, a universal armored force network. Engineers Daniel E. Noble and Henrik Magnuski adapted Edwin Armstrong's FM principles to battlefield use, encasing laboratory precision in shock-mounted steel. Each set weighed 181 pounds and contained more than 2,700 components: capacitors, resistors, crystal oscillators that held frequency within 0.01%, even under cannon fire. The first production orders were barely 18 months old when the Shermans of Kasserine went into action. Yet the difference was already absolute. German intercept units monitoring the fight recorded American voices with clarity unheard of in combat. Their transmissions are entirely free of interference, noted a 10th Panzer Division report. They converse as if on telephone lines. To U.S. tank crews, it felt ordinary. They had never known combat without radio conversation. Platoon leaders relayed artillery grids. Gunners warned each other of flank threats. Crews shared targets, ammunition counts, even mechanical failures. For the first time in the history of war, machines of steel could think together. By afternoon, the German attack collapsed. What commanders interpreted as superior American coordination was, in fact, superior communication. The Panzerwaffe, dependent on line-of-sight signals and preset orders, fought blind against an enemy that could improvise collectively. When the smoke cleared, Rudiger scribbled one phrase in his notebook. Sie kämpfen wie eine Einheit, nicht eine Kolonne. They fight as a single entity, not a column. He did not yet know that the real weapon had never been fired from a gun barrel. It had been transmitted, clean and silent, through the electromagnetic spectrum, an advantage born not in a tank factory, but in a Chicago radio lab. The question now was how such a thing had come to be, how an invisible invention turned steel and static into the most coordinated armored force in history. July 1941. Galvin Manufacturing Company, Chicago. In a windowless workshop above the roar of assembly lines, a handful of engineers stared at an oscilloscope trace that refused to drift. What they had achieved on that humid night was not just electronic stability, it was a revolution. The curve on the screen, steady, unwavering, proved that Edwin Howard Armstrong's theory of frequency modulation could survive inside a combat vehicle. The men watching it understood the stakes. Daniel E. Noble, 35, Director of Research, had spent the previous 2 years convincing the U.S. Army Signal Corps that FM was no longer a laboratory curiosity. Amplitude modulation was simple, cheap, and familiar, but its vulnerability to interference was fatal in armored warfare. Each spark from an ignition coil could obliterate orders. An FM signal, by contrast, ignored static. If built correctly, it could deliver a human voice through the metallic thunder of tank combat as clearly as a telephone call. The challenge was making it work in steel. Tanks vibrated violently. Their temperatures swung from freezing nights to engine-heated days over 60-degree gusts. Vacuum tubes failed under shock. Coils drifted off frequency. Connectors loosened. Henryk Władysław Magnuski, a Polish radio engineer who had escaped Europe in 1939, solved the problem with crystal control. He built oscillators whose quartz crystals vibrated at exact frequencies, unmoved by heat or motion. That single decision turned FM from theory into weapon. Noble and Magnuski presented their prototype to the Signal Corps in June 1941. The unit, designated SCR-508, linked 2 BC-603 receivers and 1 BC-604 transmitter in a single rack assembly weighing 181 pounds. It transmitted 25 watts on 20.0, 27.9 megahertz and offered 10 crystal-locked channels, enough for a tank company to speak across miles without tuning knobs or guesswork. For the first time, every crew member could hear orders through throat microphones and noise-canceling headsets, a radical departure from the hand signal chaos that had defined mechanized warfare since 1917. The Army approved production on July 26, 1941. Motorola, Galvin's new brand name, converted its automobile radio lines to war output almost overnight. Vacuum tube plants in Illinois and Indiana ran around the clock. Each SCR-508 contained over 2,700 precision parts, and every unit had to survive a 24-hour vibration test before acceptance. By late 1942, thousands were rolling off the lines, destined for M3 Lee and M4 Sherman tanks assembling in Detroit Arsenal and Fisher body plants. To understand its significance, one must remember the state of radio warfare before it. Since the First World War, communication had depended on amplitude modulation or Morse code. A tank crew at full power generated so much electrical noise that AM messages arrived as bursts of static. To converse, commanders used flag signals, colored flares, or dispatch riders. It was a system of delays measured in minutes, eternities on a battlefield. FM erased those minutes. The theory was pure physics. AM varied the height of a wave. FM varied its spacing. Static, lightning, motors, gunfire added spikes to amplitude but barely touched frequency. When Armstrong demonstrated his FM broadcast from Alpine, New Jersey, in 1935, they were so clear that listeners accused him of playing phonograph records. In 1941, that same clarity would become a military advantage measured in lives saved. The Signal Corps lab at Fort Monmouth tested the prototype under combat conditions. They mounted it in a Sherman hull, drove through mud, and fired the main gun while operators spoke. The recording showed a voice still intelligible amid explosions. A German FUG-5 radio tested for comparison disintegrated into static the moment the engine started. What the engineers did not know was that they were inventing the backbone of a doctrine. When the first Armored Force Manual mentioning the SCR-508 was printed in 1942, it quietly redefined the word communication. Every tank was a transceiver, every platoon a network. Orders could flow upward as well as down. The structure of command itself was changing. The shift was so profound that most officers missed it. They saw a radio. They did not see an information system. Only later would they understand that Noble's oscillator and Magnusky's crystals had done what no weapon ever had, made a machine capable of thinking collectively. By autumn 1942, the first armored battalions trained with full radio outfits at Fort Knox. Crews learned to navigate by voice alone. Commands, grid references, fire corrections, all spoken in real time through headsets that filtered out the deafening rumble of continental radios. A doctrine of instant coordination took shape, replacing the signal flag choreography of 1939 with fluid conversation. In laboratories and factories, the Americans were building an army that could hear itself think. The Germans did not yet realize that their future defeats had already been transmitted on a frequency they could not receive. Soon, that invisible weapon would speak for the first time in battle. November 8th, 1942, North Africa. Before dawn, the invasion fleets of Operation Torch reached the coasts of Morocco and Algeria. Inside the pitching hulls of landing craft, U.S. tank crews checked the glowing dials of their new radios. The sets hummed with power, crystal oscillators holding steady, despite the salt air and vibration. To most of these men, it was just equipment. To the enemy, it would soon appear as sorcery. When the first M3 Lees and M4 Shermans rumbled ashore near Safi and Fadala, they carried the full weight of an experiment. Whether the theories forged in Chicago workshops could survive real war. German observers from General Nering's 10th Panzer Division watched the American landings with confidence. They had fought British armor for 2 years and knew how cumbersome Allied coordination could be. In desert warfare, delays were death, and British formations, hampered by fragile radios, still relied on flags and runners. But the Americans were different. As daylight broke, columns of Shermans moved inland through broken ground, each tank commander speaking calmly into a throat microphone. Red 2 left 200 yards. Enemy 8 gun on the ridge. Roger, engaging. The voices overlapped cleanly, each riding a separate frequency on the SCR-508's 10-channel net. Within seconds, a trio of tanks adjusted their guns, fired, and shifted formation without ever seeing each other. German units attempting interception reported something uncanny. Their FUG-5 receivers, tuned to the same general range, heard faint English phrases, unbroken, static-free. The clarity astonished them. German tankers, accustomed to struggling through bursts of interference, couldn't believe that such communication was possible while engines were running and artillery thundered around them. One captured signal log from the Afrika Korps Nachrichtenabteilung recorded the note: American tanks transmit as though wired together. Impossible under AM physics. The physics was FM. The SCR-508's 25-watt transmitter cut through engine noise and electrical discharge that crippled AM sets. Frequency modulation ignored amplitude distortion. The crew could shout over a running Continental engine and still be understood miles away. Range tests made at Orange showed voice contact at 7 miles on the move and 15 when halted, 3 times farther than any German tank net could achieve. The contrast was immediate. A typical German platoon of 5 Panzers carried 1 FUG-5 transceiver and 4 receivers. The leader issued orders, the others obeyed in silence. When his tank was destroyed, command died with him. The Americans, by contrast, had created a horizontal network. If a platoon leader fell, another voice took over instantly. Coordination was not a person, it was a frequency. For the first time, armored units could improvise under fire. When Colonel Ernest N. Harmon's 1st Armored Division met the Afrika Korps near Taburba, his tank commanders fought a running battle across 30 miles of desert. They directed artillery strikes by radio while maneuvering their own formations, warning infantry of ambushes and redirecting reserves, all within minutes. British liaison officers, accustomed to command delays measured in hours, described it as mechanized telepathy. In Tunisian operations reports, Axis intelligence grudgingly acknowledged the effect. American radio discipline and coordination are exceptional, wrote the German 10th Panzer intelligence officer in December 1942. Their tanks cooperate with artillery as one arm. They attributed this to training, unaware that the secret was technological. Inside American command tents, the learning curve was steep but rapid. Crews practiced nets within nets, with company leaders monitoring 2 receivers at once, one for their platoon, one for battalion command. For the first time, an armored commander could speak to artillery, infantry, and logistics simultaneously. Even aircraft could patch in through liaison sets. The battlefield became an audio network linking earth and sky. Among the first to recognize what was happening was Major General Jacob Devers of Armored Force Headquarters. In a 1943 memo to Washington, he wrote, "Our new FM equipment is doing for tank tactics what the internal combustion engine did for mobility. It has made armor into an organism." The Germans learned of this organism the hard way. At Kasserine Pass in February 1943, scattered American units, though beaten tactically, displayed a form of coordination that alarmed captured enemy officers. Even in retreat, their tank crews remained in touch, calling for covering fire, reorganizing on the move, and transmitting grid references to artillery batteries 20 miles away. To the Wehrmacht, it was uncanny efficiency. To the Americans, it was simply procedure. After Kasserine, the Germans began intercepting and recording the strange, interference-free chatter of Allied frequencies. Their engineers, analyzing the waveforms, found something they did not expect: constant amplitude, variable spacing. They had heard FM for the first time. The invisible revolution had announced itself, not with gunfire, but with a clear human voice echoing through static-filled air. From the dust of North Africa, the unseen network was spreading east, toward the mountains of Italy, where terrain would reveal its full power. Spring 1943, Tunisia had fallen. The German Afrika Korps lay in captivity, and the American armored divisions, blooded but unbroken, began moving north toward Sicily and Italy. For the first time, tanks, artillery, engineers, and air support were linked not by couriers or flares, but by constant conversation. The revolution that began in desert heat was about to climb into the mountains. In theory, mountains should have killed radio. Valleys bent signals, ridgelines blocked transmission, and AM waves scattered into static. But in practice, American tank crews found that their new FM radios behaved differently. The frequency modulation of the SCR-508 resisted distortion from echoes and signal reflections. Where the Germans heard silence, American crews heard clear instructions bouncing cleanly through stone corridors. At Salerno and later at Cassino, platoons of Shermans operated miles apart in terrain that should have rendered them deaf to command. Yet they coordinated ambushes, called for airstrikes, and moved as if tethered by wire. A single armored company might occupy 3 valleys and still respond to one voice on Channel 3. When artillery observers requested fire, tanks relayed their grid to gunners miles behind them, their signals strong enough to cut through thunder and rain. In battle diaries, the difference appeared almost supernatural. "Our tanks talked through mountains," wrote Lieutenant Jack Morrison of the 756th Tank Battalion. "The Germans thought we had hidden cables." German divisions in Italy struggled with their own systems. The standard Fuji-5 set still operated on amplitude modulation, its 10-watt signal weakening dramatically when tanks moved or engines revved. Engine magnetos threw interference into the circuits, producing bursts of white noise that swallowed speech. As Allied air raids intensified, power supply cables were shortened, shielded hastily, and grounded to hulls with makeshift straps. None of it worked. Radio range fell to a kilometer in motion, sometimes less. Panzer units reverted to colored flares, visual signals, or shouting across fields, anachronisms on a modern battlefield. Meanwhile, American tank commanders were forming habits that would define armored warfare for decades. They spoke in terse, coded brevity codes: Able, Baker, Charlie, across networks that included infantry, engineers, and air support. The entire battlefield began to sound like an orchestra tuning to the same pitch. A platoon commander could contact an artillery battery, report coordinates, and within minutes, 105 mm shells would walk across an enemy ridge. A forward observer could reroute an armored column in real time. Commanders in half-tracks listened to 2 nets simultaneously, one for their own formation, another for division command, through the dual receiver configuration that Noble and Magnusky had designed years earlier. After-action reports from the U.S. II Corps described engagements coordinated across 50 miles of broken terrain. "We no longer maneuver as isolated battalions," wrote Colonel Paul Robinette. "We maneuver as parts of a single, living mechanism." The SCR-508 had become that mechanism's nervous system. German signals intelligence units noted this with growing alarm. In August 1943, the 14th Panzer Division's communications section reported that American armored units were maintaining voice contact at ranges previously considered impossible for VHF. They captured one disabled Sherman near Naples and found the radio inside, dust-coated, bullet-scarred, but still functional. The report concluded, "It appears the Americans have achieved immunity to interference." In reality, the immunity came from physics and production. The precision ground quartz crystals in each transmitter maintained their frequency despite heat and shock. Motorola factories produced tens of thousands monthly, each cut to exact dimensions and tested in temperature chambers. The German Fuji-5, by contrast, relied on hand-tuned variable capacitors that drifted with every vibration. Tank crews spent precious minutes adjusting knobs, chasing a signal that refused to hold steady. By late 1943, the psychological effect was unmistakable. American crews fought with confidence born of connection. Even when separated by smoke or terrain, they knew someone was listening. German crews fought alone, each engagement a blind duel. Otto Carius, commanding Tigers on the Eastern Front, later wrote that the worst moment in tank combat was silence, when radio failed and each vehicle became an island. American crews never experienced that silence. The shift extended beyond tactics. It transformed doctrine. U.S. field manuals now defined an armored command not merely by tanks but by radio nets, command, platoon, artillery, and air, all synchronized. The term network entered operational vocabulary years before computers would claim it. When Allied forces prepared for Operation Overlord, these same lessons traveled with them. On the decks of landing ships at Weymouth, England, tank crews checked the familiar green boxes bolted to their hulls, switched through channels 1 to 10, and heard the reassuring crackle of static that meant connection. In the coming storm, they would coordinate not only with each other but with destroyers offshore and aircraft overhead. The radio network born in desert sand was about to invade Fortress Europe. Across the channel, the Germans had no idea that the most dangerous weapon coming toward them was invisible, weightless, and already tuned to the right frequency. June 6, 1944, Normandy. As dawn spread over the English Channel, the air was thick with static and salt spray. Aboard landing craft packed with M4 Shermans, radio operators tuned their sets one last time before the ramps dropped. Each dial glowed faintly beneath red blackout bulbs. 20.8 megahertz, Channel 2, Battalion Command. Voices crackled across the water, armored companies talking to destroyers, destroyers answering back. The invasion of Europe was being coordinated not just by men and machines, but by an electromagnetic chorus that stretched from beachhead to fleet. When the first tanks rolled off the ramps onto Omaha and Utah beaches, their radios came alive under fire. Naval spotters relayed targets from offshore. Tank commanders adjusted bearings and elevation by voice alone. Over 1,000 separate transmitters shared the same invisible spectrum, yet order held. The SCR-508 had turned chaos into conversation. At 0917 hours, a destroyer off Utah received a call from a tank commander on the sand. Target, bunker, grid 45 Charlie 2, fire 1. The reply came through instantly. The destroyer's guns thundered, shells landing within 50 meters of the mark. To the Germans watching from the bluffs, it seemed impossible that tanks crawling through surf could summon naval gunfire with such precision. The network linking land and sea worked without a single wire, but the hedgerows behind the beaches revealed a flaw that even American ingenuity hadn't foreseen. The tank radios, operating in the 20 to 28 megahertz band, could not communicate directly with the infantry's SCR-300 sets, which transmitted between 40 and 48 megahertz. The result was deadly. In the narrow lanes of the bocage, German soldiers armed with Panzerfausts crept within 30 meters of tanks before being seen. Infantry units, unable to warn their armored support, watched helplessly as Shermans exploded in the sunken roads. Field reports poured into headquarters. Infantry can hear tanks, but tanks cannot hear infantry. It was not a tactical failure. It was a gap in the spectrum. The solution came not from engineers, but from field improvisation. Somewhere near St. Lo, a sergeant in the 2nd Armored Division welded an ammunition box to the rear plate of his Sherman and mounted a field telephone inside. The wire ran through a hole in the armor to the crew intercom. When infantrymen lifted the receiver, they could speak directly to the tank commander inside. The idea spread within days. By July, official orders authorized the modification. The EE-8 field telephone, a $20 device used by linemen, had bridged the gap between armor and infantry that millions of dollars of research had overlooked. Photographs from Operation Cobra show infantrymen with muddy hands gripping telephone receivers bolted to Sherman hulls while machine gun fire raked the fields around them. The line between life and death now ran through a single wire, no thicker than a pencil. Operation Cobra began on July 25, 1944. Under the blast of 1,500 Allied bombers, the tanks of the 2nd and 3rd Armored Divisions surged through the shattered German front near St. Lo. The radio networks held firm under the most intense electromagnetic congestion of the war. Tank commanders switched seamlessly between channels, company, battalion, artillery liaison, coordinating more than 200 vehicles in motion. One observer from the Army Signal Corps wrote afterward, "It was like listening to a single conversation spoken by 100 voices. Destroyed bridges, detours, even airstrikes were redirected through the net within minutes. The speed of American coordination stunned the German defenders of the Panzer-Lehr Division. Where their reports took hours to reach Corps Command, American units executed new orders in seconds. The battlefield was no longer a field. It was a living circuit. For all their industrial prowess, the Germans could not comprehend the scale of this connectivity. Their panzer formations, still using AM Fuji-5 radios, found their transmissions lost in the electric chaos of battle. Each destroyed command tank silenced an entire platoon. They fought blindfolded, while American units navigated by sound alone. In Normandy's thick hedgerows, the American advantage was measured not in armor thickness or gun size, but in words transmitted across invisible air. And when the gap between tank and infantry was closed by a humble telephone box, even the smallest voice could guide a 40-ton machine. By the time the breakout reached Avranches, American radio discipline had evolved into instinct. Entire divisions moved as synchronized waves of signal and steel. Every tank could talk. Every tank could listen. The battlefield was no longer silent. From the hedgerows of Normandy, the network expanded again toward the open plains of France, where speed, communication, and doctrine would fuse into a single weapon. August 1944, northern France. The roads from St. Lo to Paris filled with dust, fuel smoke, and radio traffic. Through the open turrets of advancing Shermans, voices overlapped in disciplined rhythm. Each call sign, Red Leader, Able 2, Charlie 3, linked a network now stretching across an entire front. This was no longer about one radio set per tank. It was about an army speaking in real time. Every armored column, artillery battery, and reconnaissance plane wired by frequency rather than wire. The doctrine behind it was born not from textbooks, but from the shock of early failure. At Kasserine, American units had discovered what happened when communication broke down. At Cobra, they learned what happened when it didn't. From that point, communication became the foundation of maneuver. The armored divisions no longer fought as rigid regiments, but as combat commands, ad hoc task forces that could form, fight, and dissolve within hours. The glue was radio. The 4th Armored Division, under Major General John S. Wood, became the model. In September 1944, near Ericourt, Wood's Shermans faced the German 111th and 113th Panzer Brigades, units equipped with the new Panther tanks, heavier armor, longer guns, and superior optics. On paper, the Americans should have been annihilated. Instead, they outmaneuvered their opponents through communication. Each Sherman transmitted enemy sightings instantly. Tank destroyers repositioned before German formations could react. Artillery observers, sitting in command tanks with twin receivers, called down fire within minutes. By the end of 3 weeks, 281 German armored vehicles lay destroyed for the loss of 41 Shermans. The kill ratio, 7-to-1, defied logic until one understood that information moved faster than steel. Reports from captured German officers revealed their confusion. They believed American radio discipline reflected extraordinary training, not technology. Their gunners must be connected by telephone, one wrote. Their coordination is uncanny. The German High Command never realized that every tank in a U.S. platoon could act as command vehicle. They continued targeting tanks with extra antennas, unaware that all were transmitters. The same advantage-shaped air support. The SCR-522 aircraft set shared compatible frequencies with the SCR-508. Tank commanders could talk directly to fighter-bomber pilots overhead. Near Montélimar, a platoon surrounded by German infantry called in a P-47 strike by simply switching channels. Pilots dropped ordnance within meters of friendly armor. Precision unheard of in 1940. Within the U.S. Army, this seamless connectivity evolved into a philosophy. Control through communication became the motto of Armored Force Command. Orders were no longer top-down. They were simultaneous, flowing through overlapping nets. Commanders described it as fighting with eyes open. The Germans could not adapt. Even with superior tanks, they were trapped in 19th century command structures. Their reliance on hierarchical messaging and limited transmitters meant every decision required authorization from above. When a commander died, so did initiative. American flexibility, enabled by universal radios, turned chaos into advantage. Production mirrored doctrine. By late 1944, Motorola and its subcontractors had delivered more than 50,000 SCR-508 family sets, enough for every tank produced. Each unit contained dual BC-603 receivers, allowing simultaneous monitoring of company and platoon nets. Power supplies automatically regulated 12 or 24-volt systems, filtering electrical noise that crippled enemy sets. German radios, powered directly from vehicle generators, picked up every ignition spark as static. The difference could be heard. American tank nets crackled with short, precise messages, words compressed into efficiency. German crews shouted over interference, missing half of what was said. The sound of modern warfare had changed. It was cleaner, faster, colder. The doctrine spread beyond tanks. Armored infantry half-tracks carried SCR-528 sets tuned to the same frequencies. Self-propelled artillery mounted long-range FM transmitters, creating continuous command loops from platoon to corps. What began as a single tank set had become a layered network extending from front lines to headquarters hundreds of kilometers away. The battlefield itself had become an electrical grid. When General Omar Bradley reviewed after-action reports from the French campaign, he noted a pattern. Divisions that maintained radio contact advanced twice as fast as those that didn't. Communication equaled momentum. The German army, still bound by physical messengers and telephones, vulnerable to air attack, could not match that pace. By autumn, Allied formations were moving across France at a speed no staff college had predicted. The Germans called it Bewegungskrieg, war of movement. But this was not Guderian's vision reborn. It was his inversion, mobility powered by networks instead of orders. At Aracourt, an American tanker described it simply, "We don't fight line to line anymore. We fight link to link." That link would soon extend across the Rhine, where silence itself would become Germany's final enemy. March 7th, 1945, west bank of the Rhine. The morning haze clung to the river like smoke from an unseen fire. Along the bluffs above Remagen, German anti-aircraft crews stared at the valley below, where American armored columns rolled forward, faster than reports could reach headquarters. To Field Marshal Walter Model, commanding Army Group B, the situation defied all logic. The Rhine had always been Germany's last wall. Yet in the space of hours, that wall was being crossed, not by brute force, but by coordination so precise it seemed mechanical. At 1350, scouts of the U.S. 9th Armored Division radioed the words that would end the war's last illusion. Bridge at Remagen, still standing. Within 60 seconds, The message traveled through division nets, Corps headquarters, and up to 1st Army Command. The network built around the SCR-508 had reached maturity, a web of voice circuits stretching from individual tanks to theater command, each connection instantaneous. While German telephones lay in twisted piles under bomb craters, American signals coursed invisibly through air. Orders came back down just as fast. "Secure it! Cross immediately!" No staff conference, no written approval. Within an hour, American Shermans were racing toward the Ludendorff Bridge, while engineers prepared demolition parties to cut the charges. The first tanks clattered onto the bridge at 15. German defenders fired sporadically, unsure whether the reports of armor already east of the Rhine were true or rumor. By the time confirmation reached Model's headquarters in Oberpleiss, entire battalions had crossed. The reason was simple. Germany had gone silent. Allied air power had shredded telephone networks from Cologne to Koblenz. Courier roads were cratered, radio frequencies choked with interference from overloaded AM sets. Model's final messages to Berlin were fragmented, his voice breaking under static. "No contact, adjacent units, situation unclear." His signal officers blamed enemy jamming. In truth, it was their own technology collapsing under strain. On the western bank, American radio discipline reached its peak. Tank commanders monitored 2 nets simultaneously, company and division, through dual BC-603 receivers. Engineers called for bridging equipment through the same channel used by artillery observers. Pilots of P-47 Thunderbolts, equipped with compatible FM sets, received coordinates directly from tanks on the bridge. Within minutes, fighter bombers were striking German guns on the far shore. The crossing of the Rhine was no longer a tactical feat. It was an information operation executed at the speed of voice. From Remagen to Wesel, divisions maneuvered as synchronized components of one vast electrical organism. Commanders issued orders across distances that once required telegraph lines. Units that had never trained together formed instant composite task forces. A tank company could merge with engineers or infantry simply by switching to a new frequency. German counterattacks disintegrated before they began. With telephone lines destroyed, field commands relied on runners and motorcycles. Messages took hours, sometimes days. Artillery support arrived after targets had moved. At Remagen, Model's Panzer reserves attacked piecemeal, unaware that American units had already reinforced the bridgehead. They were fighting ghosts, opponents whose position changed faster than intelligence could be reported. By nightfall, 8,000 men and dozens of tanks held the east bank. The SCR-508 sets in their turrets glowed softly in the dark, tubes humming, antennas trembling in the wind. The radio operators of the 9th Armored Division worked without pause, their headsets filled with overlapping voices, engineers calling for pontoons, infantry requesting smoke screens, artillery adjusting fire. The system held. It was chaos organized by electricity. On March the 17th, the Ludendorff Bridge finally collapsed into the river after days of bombardment and structural stress. But by then, it no longer mattered. 5 alternate bridges were already in place. Radio networks had replaced steel. Model's last transmission, intercepted by Allied signals intelligence 2 weeks later, was a whisper through static. "No contact with adjacent units. Fighting continues. Coordination impossible." Soon after, he would take his own life in the woods near Duisburg, a commander defeated not only by material force, but by silence. For the German army, the loss of communication marked the end of command itself. For the Americans, the constant hum of radios across the Rhine was the sound of inevitability, a mechanical heartbeat carrying an army across the final barrier. What began as an advantage in signal clarity had become the architecture of victory, reshaping not only tactics but the very psychology of war. By the spring of 1945, the war in Europe had become an experiment in human isolation. American tank crews moved through shattered towns with the quiet confidence of men who were never alone. German crews fought the same battles as solitary survivors, cut off not only from command but from one another. What separated them was not courage nor training, but the invisible bond of connection, a steady voice inside the headset that never went silent. In every Sherman, that voice meant survival. A driver could shout a warning to his gunner through the intercom. A platoon leader could call artillery within seconds of spotting a target. When tracks jammed or engines failed, nearby tanks answered immediately. Even when surrounded, a crew could whisper its coordinates, knowing someone would hear. It was not just communication. It was reassurance that the system itself was alive. German tankers described the opposite experience. Otto Carius, commanding Tigers on the Eastern Front, later wrote of the silence that filled his turret before every battle. The quiet between orders was worse than shell fire, he recalled. You felt blind, alone in a steel coffin. Each tank fought its own war, unable to warn comrades or call for help. When command tanks fell, entire platoons dissolved into confusion. At Kurland and the Ruhr, hundreds of armored vehicles were destroyed not for lack of ammunition, but for lack of contact. To American crews, isolation had become unthinkable. At night, they left their radios on, voices low, trading short bursts of chatter between units miles apart. Some operators admitted they kept the channel open simply to hear another human sound. The war's most mechanical battlefield had become its most social. Connection was now the armor no shell could pierce. That sense of unity reached its apogee under General George S. Patton. His Third Army, unleashed after Normandy, advanced across France at a speed that stunned both allies and enemies, sometimes 100 kilometers in a single day. The reason was not just fuel or logistics. Patton's divisions operated within a single radio organism. Command cars, tanks, supply convoys, and fighter bombers all shared linked frequencies. Orders transmitted from Patton's headquarters could reach tank platoons on the move within minutes. At times, he bypassed the chain of command entirely, calling battalion commanders directly over open frequency. "Tell your men," he would bark, "to keep going." And they did. The Germans could not comprehend how such vast formations could shift direction overnight. Panzer divisions spent days repositioning under confused orders that arrived by runner or field telephone. To the Americans, orders were a living stream, no longer printed, no longer static. The battlefield had become an ecosystem of voices, each adapting in real time. By 1945, the psychological balance of the war had reversed. The Wehrmacht, once the epitome of disciplined coordination, was reduced to improvising in isolation. The U.S. Army, once inexperienced and fragmented, now fought as a collective consciousness bound by radio waves. The change could be heard even in captured communications, German voices frantic and clipped, American voices calm, deliberate, almost routine. War had turned into a conversation, and only one side was still speaking. When the Ruhr pocket collapsed in April, hundreds of thousands of German troops surrendered without orders. Cut off from higher command, they no longer knew where the front line ended. American divisions surrounded them by voice, not by map, converging units guided entirely through overlapping radio nets. It was the final proof that information, not territory, decided modern war. After the surrender, Allied intelligence teams studied the psychological impact of this connectivity. American veterans, interviewed for post-war reports, spoke of an odd emptiness when they powered down their radios for the last time. We'd fought so long with someone always in our ears, one tank commander said. That silence felt wrong. German prisoners spoke of the same silence, but for them it had lasted years. We fought alone, one panzer officer told his interrogators. When our radios died, we might as well have been dead. For the Americans, the experience left a lasting lesson. That unity of communication was unity of purpose. Their radios had done more than link machines. They had linked men across fear, distance, and chaos. And when the guns finally fell quiet, what endured was not the sound of victory, but the memory of connection, the hum of voices that had carried an army through the storm. May 1945, silence returned to Europe. The radios that had once filled the air with coded voices now transmitted surrender signals and occupation orders. The electromagnetic battlefield went quiet, but the lessons it carried did not. Across ruins from Cologne to Dresden, Allied intelligence officers collected shattered German FUG radios, dismantling them beside the American SCR-508s that had outperformed them. The contrast was absolute. Two machines born of different philosophies. One built for hierarchy, the other for connection. U.S. Technical Intelligence Report number 176, compiled that summer, concluded bluntly, German armored radio equipment is approximately 5 years behind American development. The absence of frequency modulation and crystal control has limited command flexibility at all levels. For engineers who had spent the war inside factories, that statement was vindication. In Chicago, Motorola's wartime production numbers read like victory statistics. From 1942 to 1944, the company had built over 50,000 tank radio sets, enough for every Sherman produced. Each one contained 474 capacitors, 385 resistors, and precision-cut quartz crystals that maintained frequency stability within 0.01% across temperature extremes. The radios had survived mud, shock, and shell fire, but their real triumph lay in what they revealed, the power of networks. Future armies would never again fight as isolated machines. Every vehicle, every soldier, every aircraft would become a node in a web of communication. What Noble, Magnusky, and their colleagues had created in 1941 was not just a radio. It was the prototype of network-centric warfare. The transformation rippled outward. When the new German Bundeswehr formed in the 1950s, its armored doctrine began with a single sentence in its communications manual. The defeat of superior German tanks by inferior American vehicles equipped with superior radios teaches that information dominance outweighs platform superiority. Every Leopard tank built afterward carried redundant radio systems, an unspoken acknowledgement that silence had cost them a war. In the East, the Soviet Union reached the same conclusion through different means. Their engineers studied captured American and German sets, dismantling the SCR-508s component by component. They discarded the German AM circuits and copied the American FM architecture almost exactly, producing the 10 RT-26 and 12 RT-26 series that equipped post-war T-54 and T-55 tanks. By the 1960s, Soviet armor carried radios that traced their lineage directly to the battlefield network born in Chicago 2 decades earlier. America, meanwhile, refined the principle until it became doctrine. The Korean War saw FM radios as standard issue. In Vietnam, the backpack, SCR-300's descendants, the PRC-25 and PRC-77, connected infantry, artillery, and aircraft through jungle canopies where cables could never reach. Each generation shrank in size but expanded in scope. What had once filled a tank turret could now hang from a soldier's shoulder. The invisible network had become the bloodstream of the modern military. When coalition forces crossed into Kuwait in 1991, the ghosts of Kasserine and Remagen returned in digital form. Satellite links and encrypted radios created a battlefield where commanders saw in real time what their units saw. Iraqi tank forces, operating Soviet designs with outdated radios, never stood a chance. American M1A1 Abrams tanks, descendants of the Sherman in spirit, if not in form, fought with voices that traveled through space. The principles remained unchanged: clarity, coordination, and connection. In 2003, the same doctrine, now called network-centric warfare, guided U.S. armored thrusts into Baghdad. Tanks, aircraft, and infantry were synchronized by data streams instead of FM waves, yet the logic was identical. Every element of force multiplied when joined by communication. The legacy of the SCR-508 lay not in its tubes or dials, but in the truth it revealed. That victory belongs to those who can think together. Technology had merely provided the language. For historians, it marked the beginning of a new era, when information itself became a weapon, and every soldier a transmitter of power. The electromagnetic spectrum, once invisible, had become the new battlefield. Today, digital encryption and satellite constellations have replaced the soft hum of vacuum tubes, but the idea endures. Each encrypted signal, each burst of data across a network, carries the same lineage that began with a few engineers in a Chicago factory who refused to accept static as fate. They had built the first machine that allowed men to be more than individuals in war. Every Sherman that rolled across Tunisia, Italy, Normandy, and the Rhine was not merely a tank. It was a signal in a vast conversation of steel and will. And in that conversation, clarity defeated chaos, and connection, not armor, became the final measure of strength. In a world still learning to speak across distance, the faint echo of those voices remains, a reminder that even in war, understanding was the most decisive weapon of all.